A 2016 C2, question 3a. Solve this equation here. And we're between minus 180 and 180. So first of all, I want rid of this cos to make sure it's all in the same trig word. So I am going to use cos squared plus sine squared equaling 1. So cos squared is 1 minus sine squared. So my equation 1 will become 1 plus sine plus, instead of putting in cos squared, put in 1 minus sine squared minus 2 sine squared equals 0. Tidying this up, I've got minus 3 sine squared plus sine theta plus 2 equals 0. I would change all signs here to make it slightly easier. Now you can use the formula or you can factorize. It factorizes into 3 sine and sine over here, and then a 1 and a 2. So that gets me 3 on the outside, 2 on the inside. I want it to be a minus, so minus 3 plus 2. Put each bracket equal to 0. So 3 sine theta plus 2 equals 0. So sine theta is minus 2/3. Put this bracket equal to 0. So sine theta equals 1. For this one here, work out the principal angle. So go inverse sine 2/3 to give you 41.81 degrees. The interval is between minus 180 and 180, so it's a split interval. CAST. Sine is negative, so it's these two. Always draw your principal angle from the horizontal. Your first answer is minus 41.8 degrees, and your second answer is minus 180, take away 41.81, giving you minus 41.8 for your first one and minus 138. Try to remember to give it to three significant figures. Over on this side, I would draw the graph. It equals 1 when we're at 90 degrees. So theta equals 90 is your other answer. Now also from that paper, we have got question 4 to do. Patrick is going to run with his dog along a path in a local park. The path runs north. So I'm just going to draw path running north. When he's at the start of the path, he sees an oak tree on a bearing of 40 degrees. So we'll put the tree here. So tree, and bearings are always measured from the north side, so that's 40 degrees. He walks 200 meters due north along the path. So let's put him here. This is 200. And the oak tree is now 70 degrees away. So this is 70. So first of all, I can fill in here is 110. I can get this top angle. So 110 add 40 is 150. So this one's going to be 30 degrees up here. The question then says, find the nearest meter, the shortest distance from the tree to the path. So I want to find this distance here. Now, you can see two triangles in there. First of all, you've got the bottom triangle, 200, 40, 110, and 30. And then you've got the right angle triangle, so that's going to be using SOHCAHTOA, D, and 70. I can't use this triangle yet because I don't have enough information. This here side is the link between the two triangles. So I'm going to work this distance here out. So using the sine rule, because I have lots of information, so we'll use the sine rule. So 200 over sine the opposite angle equals x over sine the opposite angle. And just bring this to the other side and multiply. So 200 times sine 40 over sine 30 equals x. So x works out to be 257.115. So in my triangle here, this is now my x value. So 257.115. So I can use SOHCAHTOA to find this distance. So opposite the right angle is hypotenuse, opposite the angle is opposite, and the other side is adjacent. So just writing out SOHCAHTOA, you've got O and H, sine. So sine, the angle, is opposite over hypotenuse. Bring that to the other side and multiply. Make sure you put it behind the sine, so don't put it in front, equals D. And that works out the distance to be 241.61. Again, three significant figures. Now, that was part 1. Part 2 of that question, he walks another 200 metres. So we'll just draw out another wee diagram here. So this was the start. The tree was about here. This is 30. This was 110, 70, 40. This bit here was 200. And you have this wee distance here worked out to be 241.61. And you have this distance, 257.115. So he walks another 200 along. So let's put him here somewhere. And this is 200. Find the distance he is now from the oak tree. So I'm not very well drawn there. I'm looking for this distance here that he is from the oak tree. So I would probably, with that one there, if you use the whole big triangle, looks quite an easy one to use. So here's the tree. I'm looking for this distance. I know this is 40. And I know this side here is 400. I don't have enough information, so that triangle is not ideal. So we will try the we split triangle in the middle. So we'll go for 257.115. And this distance is 200. And this distance here is 200. And I know this angle here is 70. Now that's much more information. I can work with that one. So I've got 200, 257.115, and I've got 70. I'm looking for y. Two sides, and the in-between angle is a cosine rule. So just writing out the cosine rule, y squared is 200 squared plus 257.115 squared minus 2 times 200 times 257.115 times cosine the angle. So it's cosine 70. And when you're working these out, work out these two bits together, which gives you 106.108.1232. Take away. I'm working out this one. 35175.40366. Subtract them two and square root it to get your distance. So 266 metres.